Now, half range series are defined where the length of the interval is L or pi. So here the half range series are defined in 0 to pi and 0 to L. It is only half of that interval. There we had 0 to 2L or minus L to plus L. Here it is defined only in 0 to pi and 0 to L. So there are only two intervals here, which means the length of the interval in the half range series is pi or L. Length of the series in Fourier is 2 pi or 2L. Uska आधा है, that is why pi or L. That is why it is called as half range series. Okay. Now, there are two types of half range series. One is half range sine series, other one is half range cosine series. Okay. So first thing what we have to remember is if Fourier series is asked, then the length of the interval will be 2 pi or 2L. If half range series is asked, the length of the interval will be pi or L. That is the first thing. Second part, there are two types of half range series. One is the half range sine series, other one is half range cosine series. Now, cosine series or sine series. Now, if we have, now there are two intervals 0 to pi and 0 to L. So we will see what is the half range series defined in 0 to pi. So we have again two types of series. One is half range cosine, half range sine. So agar half range cosine likhna hai, it is defined in 0 to pi. So we have to assume that the function is an even function and write the formula for even function. Whatever Fourier series was defined for even function, that series is called as the half range cosine series in 0 to pi. Because in the half range, in the even function or odd function, we have the limits as 0 to pi. So whatever formula we have used for even and odd function, when the function is even, bn is equal to 0, which means sine terms are 0. So we can say that the remaining term is a cosine series. When the function is an odd function, a0, an is 0, only bn term will be there. So since an is equal to 0, cos terms will be 0, which means we will get only a sine series. So half range cosine series, the same formula what we had for even function. तो हमें a0 निकालना है, लेकिन चेक नहीं करना है यहाँ पे, क्योंकि फंक्शन इज डिफाइंड इन 0 to pi, वी नीड नॉट चेक कि फंक्शन इवन है या ऑड है. अगर हाफ रेंज सीरीज कोसाइन सीरीज पूछा है तो हमें अज्यूम करना है कि वो फंक्शन इवन है और इवन का फॉर्मूला लिखना है. So we know that if this is the series, then a0 will become 2 by pi integral 0 to pi fx dx. यही हमारा फॉर्मूला था जब even function when we are using those concepts. an is equal to 2 by pi integral 0 to pi fx into cos nx dx. ठीक है? So in the half range series, we need not check whether the function is an even function or odd function, because even and odd can be checked only when you have minus pi to plus pi or minus L to plus L. 0 to pi we cannot say whether the function is even or odd. लेकिन कोसाइन सीरीज पूछा है तो हमें खाली इवन का जो फॉर्मूला था वही यूज करना है. सिमिलरली अगर साइन सीरीज पूछा है तो खाली bn निकालना है and then fx will be summation bn sin nx. ठीक है? So whatever we have done, again the same concept. Only thing, the half range series are defined in 0 to pi and 0 to L. There are two types of half range series. One is cosine, one is sine. If cosine series is asked, then use the formula for even function. If sine series is asked, use the formula for odd function. We need not check whether the function is even or odd. We have to just apply the formulas for even and odd function. ठीक है? Now this is defined in 0 to pi. तो अगर पाई इंटरवल आता है तो 2 by pi हो जाता है और यहाँ पे cos nx होता है. Similarly, sin nx. Similarly, when we have half range series defined in 0 to L, the same formula. Only thing, instead of pi we get L and instead of nx we get n pi x by L. ठीक है? जहाँ पे pi आता है तो L के बदले pi पुट कर देंगे तो फिर nx हो जाता है. जहाँ पे L का फंक्शन आता है, L का इंटरवल आता है, वहां पे cos n pi x by L और sin n pi x by L. ठीक है, फॉर्मूला इज द सेम. मतलब हाफ रेंज का मतलब है कि वी हैव टू अप्लाई द फॉर्मूला फॉर इवन एंड ऑड फंक्शंस. We need not check it. Checking has to be done only if the Fourier series is defined in minus L2 plus L or minus pi 2 plus pi. Fourier series पूछा है, or the limits if it is given minus L2 plus L or minus pi 2 plus pi, then only we have to check for even and odd function. Otherwise, directly you can apply the formula for even and odd function. ठीक है, there is no other formula, same formula है, लेकिन इसलिए हमको चेक करना है कि हाफ रेंज दिया है कि फोरियर सीरीज दिया है. अगर फोरियर सीरीज दिया है तो लेंथ ऑफ द इंटरवल इज 2l. इफ हाफ रेंज सीरीज इज गिवन then the length of the interval is 0 to l. Okay, that is very important. कभी कभी क्या होता है, क्वेश्चन ऐसा होता है, फाइंड द फोरियर सीरीज इन 0 to 3, एंड देन दूसरा हो सकता है फाइंड द हाफ रेंज सीरीज for function f of x in 0 to n. तो अगर हाफ रेंज है तो the length of the interval is going to be n. अगर फोरियर सीरीज है तो length of the interval is going to be 2n. तो वो l की वैल्यू यहाँ पे डिफरेंट हो जाएगी डिपेंडिंग अपॉन इट इज अ हाफ रेंज सीरीज और फोरियर सीरीज. तो वो हमें केयर लेना है जब l की वैल्यू लिखेंगे. तो हमको पहले यही देखना है कि फोरियर सीरीज पूछा है या हाफ रेंज पूछा है. अगर फोरियर है तो 2l होता है लेंथ ऑफ द इंटरवल, और अगर क्या बोलते हैं हाफ रेंज पूछा है तो द इंटरवल इज 0 और l. द लेंथ ऑफ द इंटरवल विल बी l. Okay, so be careful in writing the value of l because all these integration everything will depend upon the value of l. So value of l has to be written correctly. So we'll do problems based on this. Same formula, whatever we have used in minus pi 2 plus pi or minus L2 plus L, same formula हमको यहाँ पे भी use करना है. Only thing we need not check whether the function is even or odd. उतना ही हमको देखना है यहाँ पे. खाली अगर हाफ रेंज दिया है, कोसाइन दिया है तो a0 an निकालना है, और अगर साइन दिया है तो bn निकालना है, जैसे हम लोग इवन और ऑड फंक्शन के लिए करते हैं. So first problem, obtain half range cosine series for f of x is equal to x minus x square in 0 less than x less than 1. Obtain half range cosine series. कोसाइन सीरीज मतलब हमको इवन फंक्शन करके ट्रीट करना है एंड देन कैलकुलेटिंग a0 एंड an. बिफोर दैट चेक द इंटरवल. यहाँ पे दिया है 0 to 1. पाई का फंक्शन, पाई का इंटरवल नहीं है. 0 to 1. So what is the length of the interval here? Length of the interval in the 0 less than x less than 1 मतलब upper limit minus the lower limit. तो लेंथ ऑफ द इंटरवल हो गया 1. ठीक है, लेंथ ऑफ द इंटरवल इन द हाफ रेंज सीरीज इज l, which means that l is equal to 1. Or in the half range series, functions are defined in 0 to l, so l value is equal to 1. The first step is write l if pi is not given in this interval. ठीक है, सबसे पहले हमें लेंथ ऑफ द इंटरवल निकालना है. तो यहाँ पे हो जाता है 1 minus 0 which is equal to 1. हाफ रेंज सीरीज आर डिफाइंड फॉर ए लेंथ ऑफ इंटरवल ऑफ l, तो मतलब l is equal to 1 हो जाएगा. तो फर्स्ट स्टेप इज l is equal to 1. That is the first step. Now calculate a0 an and substitute in the f of x formula. bn will be equal to 0 because we are calculating हाफ रेंज कोसाइन सीरीज. तो जो चेंज है वो l में ही आता है बिकॉज इट इज डिफाइंड इन 0 to l. So now what is a0? Same formula, a0 will become 2 by l integral 0 to l fx dx. The same formula we apply for even function also when we have minus L2 plus L function. So A0 is 2 by L integral 0 to L fx dx. So here L is equal to 1. So substituting for L equal to 1, we will get 2 integral 0 to 1 x minus x square into dx. Integrate karo and tell me the value of A0. X minus x square, two separate functions are given. So integrate and calculate the value of A0. What is A0? वन बाई थ्री. ओके, 1/3. ठीक है, चेक करते हैं. x का इंटीग्रेशन x स्क्वायर बाई 2, x स्क्वायर का इंटीग्रेशन x क्यूब बाई 3 between the limit 0 and 1. So when I apply the upper limit, we will have 2 into 1/2 minus 1/3. Lower limit will become 0 because you have both the functions x. So 2 into 1/2 minus 1/3. 2 into 1/2 minus 1/3. If we take the LCM, we will get 3 minus 2 upon 6. That is 1 upon 6, or that is equal to 1 upon 3. Correct. So A0 is equal to 1/3. Next, calculating AM. जैसा हमने अभी तक किया है वही है, कोई चेंज नहीं है. खाली यहाँ पे फोरियर सीरीज के बदले हाफ रेंज. तो हमें खाली लेंथ ऑफ द इंटरवल याद रखना है और कुछ नहीं करना है. हाफ है तो उसका आधा ही रहेगा. फोरियर सीरीज 2L में है तो हाफ रेंज सीरीज L में रहेगा. So we got A0 is equal to 2/3. Now calculating AM using the formula for AN. AN is 2 by L integral 0 to L f of x dx. F of x into cos n pi x by L dx. As L is equal to 1, we will get cos n pi x. Substitute for f of x. L is equal to 1 in this problem. So 2 upon L will become 2. 0 to 1. Fx is x minus x square. Cos n pi x upon 1. That will become cos n pi x. Use integration by parts or UV rule. Take the algebraic function x minus x square as u, cos n pi x as v, and use u into v. अभी तो u v पक्का हो गया होगा, all of you. So many problems we have done based on u into v. So write first bracket u, second bracket integral v, second term is minus, differentiating the first bracket, integrating the second bracket. So calculate what is AN, find what is AN. So if we use u into v, first u integral of the trigonometric function. So cos n pi x integration is sin n pi x upon n pi. फिर दो ब्रैकेट्स आ गए, बीच में माइनस है. पहला टर्म पॉजिटिव, सेकेंड नेगेटिव, थर्ड पॉजिटिव. Then the derivative of the first bracket. So x minus x square derivative is 1 minus 2x. 1 minus 2x derivative is minus 2. This is the integration of cos n pi x. Then integration of sin n pi x upon n pi. So sine integration is minus cos n pi x upon n pi. Already you have 1 n pi, so n square pi square. Again integration of this, we will get minus sine n pi x upon n cube pi cube. The next derivative of 2 will become 0, so we can stop the UV rule. Minus 2 into 1 plus cos n pi upon n square pi square. Okay. Minus 2 into 1 plus n pi. Let's check that. Apply the upper limit and the lower limit. सो अपर लिमिट जब अप्लाई करेंगे तो यहाँ पे sin n pi, which is when x is 1, sin n pi is 0. Here also the first and the third term are 0 when x is 1 and x is 0. खाली सेकेंड टर्म रहेगा, सेकेंड टर्म में x को 1 पुट करना है, x को 0 पुट करना है. So when x is 1, you have minus sign here. 1 minus 2, which is again minus sign. Okay, I've taken minus into minus is plus. Cos n pi upon n square pi square. लोअर लिमिट का और एक माइनस साइन, ऑलरेडी दिस इज प्लस, सो एक माइनस साइन लोअर लिमिट का आ जाएगा. 1 minus 0 is 1. This is also 1 upon n square pi square. Yes, correct. Minus 2 into 1 plus minus 1 raised to n. Yes, so minus sign can be taken common. And cos n pi can be replaced by minus 1 raised to n plus 1 upon n square pi square. Correct. Tejas and Harsh, both of you have got the same answer. Nice that you're using symbols and all. Very good. Okay. So an is equal to minus 2 into minus 1 raised to n plus 1 upon n square pi square. After calculating an or bn, check whether that an value is true for all the values of n. अगर नहीं है तो हमें कैलकुलेट करना पड़ेगा जो भी वैल्यू के लिए वो ट्रू नहीं है. I think this is true for all the values of n because n takes the values from 1 to infinity. So it is fine. It is true for all the values of n. Substituting in the f of x formula. Substituting in the f of x formula. Substituting in f of x, a0 we have 1 by 3, an is equal to this. L is equal to 1, substituting everything in the fx formula. A0 is 1 by 3, an is minus 2 into minus 1 raised to n plus 1 upon n square pi square. And L is equal to 1, that is why we get cos n pi x. We can simplify 1 by 3 by 1 by 2 is 1 by 6. This minus sign can be taken outside. Each step, like marks are there for each steps. A0 has some marks, an, bn, then writing f of x, calculating L, what is L also. So each step carries marks here. So if the formula goes wrong, otherwise, at least if you write f of x, you will get 1 or 2 marks. But then you have to write the formula correctly, A0, an and bn, जो भी है. उसके हिसाब से formula you have to write it. Whole chapter we are dealing with only these 3 functions, a0, an and bn. Only thing, if you are having minus pi to plus pi, minus L to plus L in a Fourier series, then we have to check for even and odd. Even if you don't do that, you can calculate again a0, an and bn. And there are 2 types of intervals we have to see, 0 to 2, that is length of interval 2 pi and then 2l. That is only the change. Next one. Obtain half-range cosine series for f of x is equal to 1 by 2 pi minus x sin x in 0 to pi. F of x is half of pi minus x into sin x. तो यहाँ पे इंटरवल दिया है 0 to pi. तो हमारे फॉर्मूला में 1 upon pi वगैरह आएगा. Now again cosine series मतलब हमको a0 और an निकालना है. bn will be equal to 0. fx is equal to 1/2. There is no L here, or L is equal to pi, we can say maybe. I think A0, which is 2 by pi integral 0 to pi fx dx. Substitute for A0 and calculate the value of A0. Substitute for fx, which is half of pi minus x into sin x. Take half outside, 2 and 2 will get cancelled. Integrate pi minus x into sin x between the limit 0 and pi. तो यहाँ पे हमको u into v apply करना पड़ेगा because pi minus x is an algebraic function and sin is a trigonometric function. So use u into v inside the integration in a0 itself. What will be the value of a0? One, okay, 1. Fine. अगर half को बाहर लिया तो half 2 and 2 will get cancelled. Remaining will be this. So use u into v. So u integral v. Pi minus x into integration of sin is minus cos. Second term is minus pi minus x का derivative minus 1 minus cos x का derivative minus sin x between 0 and pi. So applying the upper limit, pi minus pi will become 0. Which one? No, you have to show UV rule. Maybe you can check your answer with the calci, but then you have to show these steps. Don't write directly the answers. You are not supposed to use programmable calcis in maths exam. Okay, so you have to show. Maybe you can check your answers with that. The programmable calcis are not allowed only for maths. So you cannot, only normal, for normal calculations only calcis are allowed. You can check your answer maybe, but at least you have to show the u into v rule. So when I apply the upper limit, pi minus pi is 0. So minus cos pi, that is 0. This is also sin pi is 0. Lower limit mein sin 0 is 0. We will have only one term, pi minus 0 into cos pi is minus 1. Already you have a minus sign, so we'll get totally pi upon pi, which is equal to 1. At least you have to show that step, u integral v वाला लिखो, बाद में तुम आंसर लिखो तो भी चल जाएगा. Okay, at least you have to show that step, u into v minus जो भी है. And that's not a difficult thing, na? Write u, write integral v, write in 2 brackets and go on differentiating the first bracket and integrating the second brackets. Okay, now calculate an. An is equal to 2 by pi integral 0 to pi fx dx. जहां पे L इंटरवल दिया है वहां पे 2 by L आएगा. जहां पे पाई इंटरवल है वहां पे 2 by L, 2 by pi. वही हमको चेक करना है कि हमने फॉर्मूला बराबर लिखा है कि नहीं. Then you have, because here we have mixed problems, 0 to pi, 0 to L. So calculating an. Again use u. Now before using, now here we have 3 functions. Pi minus x is there, sin x is there, and cos nx. So we cannot apply now u into v because we have 3. But the 2 functions are trigonometric functions. So we can simplify this trigonometric functions and then apply u into v. So how to simplify now? Sin a cos b. Use the formula for 2 sin a cos b 2 sin A cos B. Sin A cos B comes in the expansion of sin A plus B and sin A minus B. So using sin A cos B, 2 sin A cos B, sin A plus B plus sin A minus B. So using sin A cos B for these two terms, where A is equal to x and B is equal to nx. So A plus B will become x plus nx. A minus B will become x minus nx. 2 is not there, so multiplying and dividing by 2. So using the formula 2 sin A cos B for these two trigonometric functions. Since 2 was missing, we have multiplied and divided by 2. Pi minus x वैसे ही रहेगा. Sin A cos B के बदले sin A plus B. Now A plus B will become x plus nx. x plus nx में x common है, तो x बाहर लेके 1 plus n बचता है. Plus sin of A minus B. A minus B is x minus nx. Again x is common, so 1 minus n into x. Now separate and then use u into v for both the terms. अभी pi minus x को दोनों साइन फंक्शंस के साथ में लेना है और उसको u into v करके इंटीग्रेट करना है. In the next step, apply uv rule to integrate the given function. So separating that, writing pi minus x into first sine function plus pi minus x into sine of 1 minus n into x. Now use u into v for both the terms. यहाँ पे भी u into v और यहाँ पे भी u into v apply करना है. So we'll have totally 4 terms. So first term का u into v पहले लिखना है, तो pi minus x into sin 1 plus n of x. तो यहाँ पे u first bracket है और sin वाला term v वाला term है. तो now first term into integration of sin, which is minus cos upon 1 plus n. Then minus pi minus x का derivative -1 और इसका integration. 1 का derivative 0 हो जाएगा, तो we will have only 2 terms when we use uv rule for the first term. Similarly for this, for it सब same है, खाली 1 plus n के बदले 1 minus n रहेगा. Using u into v rule for both first term and the second term. जब तक डेरिवेटिव कांस्टेंट नहीं आता है तब तक यू राइट द डेरिवेटिव्स एंड गो ऑन इंटीग्रेटिंग द v फंक्शन. जब डेरिवेटिव कांस्टेंट आ गया तो यू कैन स्टॉप दैट फंक्शन बिकॉज नेक्स्ट डेरिवेटिव विल बिकम 0. फिर नेक्स्ट फंक्शन लेना है, फिर से u इंटीग्रल v माइनस ऑफ इसका डेरिवेटिव इसका इंटीग्रेशन बिटवीन द लिमिट 0 एंड pi. अप्लाई द अपर लिमिट एंड द लोअर लिमिट. What will happen to sine of 1 plus n pi? What is the value of sine? Will it be 0 or not 0? Sine of 1 plus n into pi. Remember, n takes the values from 1 to infinity. So what is the value of sine 1 plus n into pi? What is sine? अगर n को मैंने 1 लिया सपोज, अगर n को 1 लिया तो हो जाएगा sin 2 pi. Sin 2 pi 0 है, n को 2 लिया तो sin 3 pi. 3 pi is also 0. So all these sine terms will become 0. खाली cos के terms बचेंगे. Yes, cos के terms बचेंगे. तो applying the upper limit, तो first term में अगर x को pi put किया तो pi minus pi 0. This is also 0. यहाँ पे pi minus pi 0. यहाँ पे sin 0. तो ये चारों टर्म जीरो हो जाएंगे व्हेन वी अप्लाई द अपर लिमिट. नाउ लोअर लिमिट. तो लोअर लिमिट में x को जीरो पुट करना है तो खाली साइन वाले टर्म जीरो हो जाएंगे. तो व्हेन यू अप्लाई द अपर लिमिट खाली ये दो टर्म्स बचेंगे, फर्स्ट एंड द थर्ड टर्म. तो व्हेन वी हैव पाई माइनस जीरो, पाई माइनस जीरो इज पाई, this minus sign is for the lower limit. So minus of pi minus 0 into cos 0 is 1. So minus 1 upon 1 plus n. Similarly, फिर से lower limit के लिए minus sign. Pi minus 0 is pi minus 1 upon 1 minus n. When we apply the upper limit, everything is becoming 0 because we are having pi minus pi terms in with the cos function and sine terms. Sine is already equal to 0. But other two terms are becoming 0 because when x is pi, you will get pi minus pi. तो पूरे चारों के चारों टर्म 0 हो जाते हैं जब x की वैल्यू पाई होती है. सिमिलरली ना x की वैल्यू 0 पुट करनी है. जब x की वैल्यू 0 है तो सेकेंड और फोर्थ टर्म 0 हो जाता है. बाकी विल गेट टू टर्म्स व्हेन x इज 0. टेक pi कॉमन and cancel out with the outside pi. So we will have minus into minus will become plus, here also plus. So pi will get cancelled, 1 upon 1 plus n plus 1 upon 1 minus n. Take the LCM, simplify, cross multiply. So 1 upon 1 plus n plus 1 upon 1 minus n will become 1 minus n plus 1 plus n upon 1 plus n into 1 minus n. N will get cancelled, half of 2 into 1 minus n square. Or I can write 1 upon 1 minus n square. Now 1 upon 1, I told you after calculating a0 or bn, check whether this function, this value of an is true for this, whatever answer you have got, is it true for all the values of n? So what about here? An value, is it true for all the values of n? No. Why? Because when I put n is equal to 1, the denominator becomes 0 or we get the function as infinity. तो हमें क्या निकालना है separately? This function is not, this value is not true for n equal to 1. Or 1 upon 1 minus n square is true only for n not equal to 1. तो हमें a1 निकालना है. So calculating a1 separately. an के फॉर्मूला में n को 1 पुट करना है और a1 निकालना है. So calculate a1. So a1 के an के फॉर्मूला में जब n is equal to 1, तो here we will get cos 1x. Normally cos nx रहता है, तो a1 निकालेंगे तो cos x हो जाएगा. Again, we have to combine the trigonometric functions and then use u into v to integrate. So sin a cos a. Sin a cos a is sin 2a upon 2. Or we can take that 2 inside and 1 by 2 outside. So combine the trigonometric function sin a cos a. 2 sin a cos a is sin 2a. We can write, I have taken this 2 with the sin a cos a, so we will get sin 2a and this 1 by 2 is outside. Again use u into v and tell me what will be the value of a1. Use u into v and see what is the answer we get. Try karo u into v again. Again I'm telling you, don't separate pi and pi minus x. Don't write as two terms and then u into v. Pi minus x को एक ही term consider करो and then apply u into v, क्योंकि pi का derivative next step में 0 ही हो जाता है. The first bracket will be pi minus x, second bracket will be the integration of sin 2x. So what is the value of a1? Is it 0? 1 by 4. Okay. Okay, what others? Okay, is it 1 by 4 or 1 by 2? 1 by 4. Okay, let's check that. So again, u into v, u integral v minus derivative of u is the integration. Applying the upper limit, pi minus pi will become 0, sin 2 pi will become 0. Lower limit में x की value 0 है, तो lower limit का minus sign and this minus sign will become positive. So we will have pi into cos 2 pi. Cos 2 pi value is equal to 1. So 1 by 2. So it is equal to 1 by 4. Correct. So A1 is equal to 1 by 4. Substituting A0, AN and A1 in the series for, there is a half range series for f of x. Substituting in the, तो अभी जो हमने an निकाला था, that is true for n varying from 2 to infinity. तो हमें a1 separately लिखना पड़ेगा. So we have to write it in this form because this value is not true for n equal to 1. तो हमने यहाँ पे n equal to 1 को separate कर दिया है. तो a1 cos x plus बाकी जो है वो n is equal to 2 to infinity. So separated an cos nx as a1 cos x plus summation n varying from 2 to infinity an cos nx. a1 के बदले 1 by 4, a0 के बदले 1 and an के बदले 1 upon 1 minus n square. Move to the next problem. Find the half range sine series for fx is equal to x, 0 less than or equal to x less than or equal to 2, 4 minus x, 2 less than or equal to x less than or equal to 4. Tell me what will be the value of L. What is the value of L in example 3? Four. Okay, 4. Again, it is asked half range series. Half range series are defined in 0 to L, or the length of the interval in half range series is L. Here the length of the interval is 4 minus 0, which is equal to 4. So L is equal to 4. Or it is defined in 0 to 4. So L is equal to 4. कैसे भी ले सकते हैं. So L is equal to 4. हमें साइन सीरीज निकालना है. साइन सीरीज मतलब खाली bn निकालना है, a0 an नहीं निकालना है. So only calculating bn. So we know summation n varying from 1 to infinity bn sin n pi x by L is the series for order function or sine series. Calculate bn. So bn is equal to 2 by L integral 0 to L fx into sin n pi x by L. So use the formula for bn, substitute here. That will be the half range sine series. तो जब पाई का इंटरवल नहीं दिया है तो L की वैल्यू निकालनी है. पहले चेक नहीं करना है कि इवन है या ऑड है, हमें डायरेक्टली अप्लाई करने हैं फॉर्मूलास इवन और ऑड की. साइन पूछा है तो खाली bn निकालना है, कोसाइन पूछा है तो a0 और an निकालना है. Calculating bn now. Since L is 4, so I'll get 2 by 4 integral 0 to 4 fx sin n pi x by 4. but the function is not defined. F of x is not defined in 0 to 4. It is defined in two intervals. तो 0 to 2 plus 2 to 4. इसको separate करेंगे हम लोग. 2 by 4 will become 1 by 2. 0 to 4 को लिखेंगे 0 to 2 plus 2 to 4. 0 to 2 f of x का function है x and 2 to 4 the function is defined as 4 minus x. X into sine n pi x by 4 dx plus integral 2 to 4 4 minus x into sine n pi x by 4 dx. Integrate, again two integrals are there, integrating using by parts. X into sine n pi x by 4. U into v apply करो फिर से. U integral v minus apply for both the terms and let's see what is the answer we get. सबसे पहले टर्म का u into v, तो पहले x लिखा, फिर साइन का इंटीग्रेशन यहाँ पे लिखा, x का डेरिवेटिव, इसका इंटीग्रेशन यहाँ पे लिखा, दैट इज बिटवीन 0 and 2. देन मैंने हाफ अंदर ले लिया है एक्चुअली. 4 minus x u इंटीग्रल v माइनस इसका डेरिवेटिव, इसका इंटीग्रेशन. Here the limits are 2 to 4, here the limits are 0 to 2. Apply the upper limit and the lower limit in both the cases. Now when we apply x is equal to 2, when we apply x is equal to 2, तो यहाँ पे 2 होगा n pi 2 by 4. n pi 2 by 4 मतलब n pi by 2 हो जाएगा. n pi by 2 we do not know what is the value of n pi by 2. n pi by 2 का मतलब अगर n की वैल्यू 1 है तो cos pi by 2, n की वैल्यू 2 है तो 2 pi by 2 मतलब pi हो गया. So we have different values of cos n pi by 2. We cannot write that as 0. तो सेम रहेगा, cos n pi by 2 वैसे ही रखना है. फिर यहाँ पे x को 2 पुट करना है. Again we will get sin n pi by 2. Sin n pi by 2 की वैल्यू भी we have different values. Sin pi by 2 is 1, sin 2 pi by 2 is 0, sin 3 pi by 2 is minus 1. So again we cannot write a general value, we have to keep it as sin n pi by 2. Lower limit में ये वाला 0, x is 0 and sin 0 0. वैसे यहाँ पे upper and lower limit apply करना है. So in the next step, I've applied the upper limit as x equal to 2. So n pi 2 by 4 will become n pi by 2. This will become sin n pi by 2. Lower limit पूरा 0 हो जाएगा because when x is 0, first term 0 and sin 0 is 0, second term 0. तो दोनों term 0 हो जाएंगे when we have the lower limit. फिर यहाँ पे upper and lower limit. Upper limit में जब x को 4 पुट करेंगे तो first term is 0. यहाँ पे अगर x को 4 पुट करेंगे तो n pi 4 by 4. 4 will get cancelled, we will get sin n pi, that is again equal to 0. So पहला, both the terms are 0 when x is equal to 4. Now apply the lower limit. The lower limit has a negative sign. 4 minus 2 is 2. Cos n pi 2 by 4 is minus cos n pi by 2. फिर से lower limit आएगा, इसके लिए plus हो जाएगा minus 1 into sin n pi by 2 upon n pi by 4 the whole square. And do it systematically, apply the upper limit and the lower limit. Now tell me which terms will remain. Sin का term रहेगा या cos का term रहेगा आंसर में. Simplify everything. See whether sin term remains in the answer or cos term. cos के कितने, दो टर्म्स है, cos के भी 2 है, sin के भी 2 है. cos का क्या है यहाँ पे -2 cos n pi by 2 upon n pi by 4. अगर मैंने हाफ कॉमन बाहर लिया है तो -2 into cos n pi by 2 upon n pi by 4. यहाँ पे होता है +2 cos n pi by 2 upon n pi by 4. मतलब cos टर्म्स कैंसिल हो जाएंगे. ना sin कितना है, यहाँ पे प्लस sin n pi by 2 upon, यहाँ पे है प्लस sin n pi by 2 upon. दोनों sin वाले टर्म्स ऐड हो जाएंगे. So we can write 2 times sin n pi by 2 upon n pi by 4 the whole square. When we simplify, half is taken common. सो कॉज वाले टर्म्स कैंसिल हो जाएंगे, साइन वाले टर्म्स ऐड हो जाएंगे. तो वी हैव 2 times sine function. So sin n pi by 2 upon n pi by 4 the whole square. Again this 2 and 2 will get cancelled. If we open this bracket, we will get 16 upon n square pi square. So we will have 16 n pi by 2 upon n square pi square. Yes. So be careful, sine of n pi is 0. Sine of n pi by 2 is not 0. So this Bn is true for all the values of n, directly substituting in the fx function. Substituting in the fx function. Substituting Bn is equal to, that is fx is equal to summation Bn sine n pi x by L. L is equal to 4 here and Bn is equal to this. f of x, यहाँ पे Bn का जो आंसर आया उसको यहाँ पे सब्स्टिट्यूट करना है. 16 sine n pi by 2 upon n square pi square sine n pi x by 4. Next problem, half range sine series for f of x is equal to, we have 3 intervals. 0 to pi by 3 में pi by 3 वैल्यू है, pi by 3 में 2 pi by 3 में 0 है, 2 pi by 3 to pi is minus pi by 3. So the function is defined in 0 to pi. Pi वाला interval है 0 to pi. So writing the half range sine series for 0 to pi. Again Bn निकालना है और यहाँ पे sin nx आएगा instead of sin n pi x by n. या फिर you study only one formula which is sin n pi x by L, put L is equal to pi here, so we'll get sin nx. हमेशा एक ही याद रखो, cos n pi x by L and sin n pi x by L. When L is equal to pi, we will get sin nx. Calculating Bn. Two by pi integral 0 to pi fx sin nx dx. Since fx is defined in 3 intervals, we will split that integral 0 to pi as 0 to pi by 3, pi by 3 to 2 pi by 3, and 2 pi by 3 to pi. And substituting accordingly those values, f of x pi by 3, f of x 0, and f of x is minus pi by 3. The corresponding values of the functions are substituted in these integrals. Second term will become 0, only first and third interval, previous slide. Done? Okay. Bn निकालना है हमको. pi by 3 is a constant. Okay, this integral will become 0. यहाँ पे pi by 3 यहाँ पे minus pi by 3. So I can take pi by 3 common. So only we will have sin nx integration. So integrate that. Pi by 3 is taken common. So 0 to pi by 3 sin nx. And this minus sign I have written over here. 2 pi by 3 to pi sin nx dx. Now integrate this function. As there is only one function sin nx, directly we can integrate. Sin nx integration is minus cos nx upon n. Apply the upper limit, lower limit. So apply the upper limit as x equal to pi by 3, x equal to 0 in the first one, and then x equal to pi and x equal to 2 pi by 3 in the second one. Applying the upper limit and the lower limit. So when we apply the upper limit, यहाँ पे हो जाएगा n pi by 3. Lower limit का minus sign and this minus sign will become plus. Cos 0 is 1. Minus into minus is plus. Cos applying the upper limit cos n pi, and the lower limit again negative sign cos. I've taken n also outside, so cos 2n pi by 3. Can we simplify further? I think we can leave it in this form only. Again, cos n pi by 3, we're not having a single value. Cos pi by 3, cos 2 pi by 3, we have different values. We'll leave it like this only. So what is the value? What is the function? See, I've just take down this first and then cos c plus cos d. इससे कुछ फायदा होता है क्या? देखो, if you're getting a simplified form, it's okay. You can try that way. Cos c plus cos. कहाँ पे apply करोगे? Cos c plus cos d first and last. There are 3 cos functions here. Maybe we can do cos c plus. Okay, we can try that. तो क्या आएगा फिर? Cos c plus cos d अगर किया तो simplify हो रहा है क्या? Good. If it is getting simplified, that is well and good if you can. तो क्या होगा? क्या बचेगा when you do cos c plus cos d? Just check that. मैंने सिंप्लीफाई नहीं किया, वैसे ही रखा है, बट if you can simplify further. Cos c plus cos d का फॉर्मूला क्या है? 2 cos c plus d by 2 cos c minus d by 2. फिर से cos into cos हो जाएगा ना? I've kept the answer like this only and then substituted in the summation. Okay. Now, suppose we put n is equal to 1. पूरे इसमें अगर n को 1 put किया, तो what is the answer we get? The book has given different form. In the series form they have given, अगर prove that, अगर suppose पूछा हमको, तो अगर n की वैल्यू 1 है, तो what will we get the first term? हर एक जगह n को 1 पुट करना है. मतलब यहाँ पे sin x हो जाएगा, यहाँ पे 2 by 3, यहाँ पे minus cos pi by 3 plus 1 plus cos pi minus cos 2 pi by 3. Just tell me what will be the value of the function when n is equal to 1. Cos pi by 3 is 1 by 2. Cos 2 pi by 3 को हम cos pi by 3 में कन्वर्ट कर सकते हैं. Maybe try using calci and calculate the values when n is equal to 1, 2, etc. and write the series. अगर proof that पूछा है तो otherwise you can leave the answer in this form only. n को 1 पुट करें तो क्या आंसर आता है फर्स्ट टर्म? 0 है. यस, करेक्ट. 0 आता है. n को 1 2 पुट किया तो that is not required. Okay, unless it is given proof that, then only we have to get that particular form, otherwise it's not required. So the book answer what they have given is in this form. ठीक है, मतलब क्या है, जब n1 होगा, n3 होगा, n5 होगा, all these functions will become 0. It is when n is equal to 2, 4 and 5. 2, 4 and 5 के लिए 0 नहीं होता है क्या? पता नहीं. This is the book answer given. I didn't check for this part. I just checked for first and second one. I just check the values अगर वही, क्योंकि 2 और 4 के लिए मैंने चेक किया, लेकिन 5 के लिए नहीं चेक किया मैंने. Just check one more value. खाली 2 के लिए check करो. The remaining it's okay. When n is equal to 2, are we getting the answer as 1? The coefficient as 1? Yes. ठीक है. This is not required. You can keep the answer in this form also. Nothing wrong in that. It's almost time. Take one more if you want. Half range cosine series for f of x is equal to e raised to x. तो यहाँ पे चेक नहीं करना है कि फंक्शन इवन है या ऑड है, हमें खाली सब्स्टिट्यूट करना है फॉर्मूलाज में इवन और ऑड फंक्शन के फॉर्मूलाज में. f of x is equal to e raised to x. L is equal to 1 in this case. Calculating a0 and an. Since cosine is asked, we have to calculate a0 and an, and if sine is asked, then we have to calculate only bn. So calculating an, a0. L is equal to 1, so 2 times 0 to 1, e raised to x dx. Integration of e raised to x is e raised to x itself. Apply the upper limit and the lower limit. We will get 2 into e minus 1. Similarly, calculating an. an में हमें अप्लाई करना पड़ेगा ये फॉर्मूला e raised to ax into cos bx. So many places we are making use of this integration of e raised to ax into cos bx. Using the formula, I didn't write the formula here. E raised to ax upon a square plus b square, a cos plus b sine. That is the formula here. A is the coefficient of x in the exponential function. B is the coefficient of x in the trigonometric function. That is why a is 1 and b is n pi. So 1 plus n square pi square, a cos plus b sine. Apply the upper limit and the lower limit. Okay, this formula, we have to remember the standard form so that we can apply this function easily, this integration easily. Applying the upper limit and the lower limit. Sine n pi will become 0, sine 0 will become 0. We will have only the upper limit. This is the an function. Substituting everything in the f of x and writing the half range cosine series. So So only this much is there. We have one more small topic left, Parseval's identity. Otherwise, this is the main thing. Fourier series in 4 intervals, half range cosine, half range sine. यहाँ तक ही है पूरे Fourier series chapter में. Parseval's identity is just to solve the deduction part. Otherwise, it's not. So everywhere you will be asked to calculate Fourier series or half range. Fourier है तो 0 to 2l या 0 to 2 pi में होगा length of the interval. Half range तो 0 to l or 0 to pi. ठीक है, so we'll continue tomorrow. Mostly by tomorrow, Fourier series module also will get over. So thank you. See you tomorrow. Yes, thank you. Every day uploading PPTs, Rugved. Notes, maybe 1 or 2 problems I can solve extra. That's it. That the notes are same as. Still, I'll try to do that. Every day PPT, I'm uploading it. Maths notes means you're just having the problems only. I think still it is remaining some few even complex का पूरा बचा है मेरा. I'll do that.